Hello, my name is Anna Marie McKellips. I am a graduate student at the University of San Diego in the Masters of Science program in Engineering, Sustainability, and Health. My MESH project will be researching bioremediation methods of the removal of lead from contaminated soils. This presentation will go over energy implications related to my MESH project, justice implications, and who can and should address these injustices. My energy analysis was pertaining to calculating CO2 emissions from the transportation of hazardous waste, i.e., contaminated soil in roll-off dumpster trucks, from California to a municipal landfill in Yuma, Arizona. This transportation aspect is the current most commonly used method of remediation. Physical abatement and disposal of contaminated soil is one of the most energy-intensive components of my research project. Energy justice is not confined solely to a consistent demand and supply. Energy justice also incorporates the communities that are affected by the infrastructure, transportation, production, conveyance, and consumption of energy. My MESH project focuses heavily on environmental justice aspects. The Environmental Protection Agency defines environmental justice as the just treatment and meaningful involvement of all people, regardless of income, race, color, national origin, tribal affiliation, or disability, in agency decision making and other federal activities that affect human health and the environment. That people are fully protected from disproportionate and adverse human health and environmental effects, including risks and hazards, including those related to climate change, the cumulative impacts of environmental and other burdens, and the legacy of racism or other structural and systemic barriers, and have equitable access to a healthy, sustainable, and resilient environment in which to live, play, work, learn, grow, worship, and engage in cultural and subsistence practices. Some communities are disproportionately affected by environmental justice issues in the distribution of lead contamination. The National Institute of Environmental Health states that in the U.S., more African children have elevated blood levels than any other racial or ethnic group of children. Minority and lower income communities are exposed to higher levels of exposure of hazardous chemicals by their proximity to industrial waste and other pollutant sources like highways and airports. In a recent assessment of school communities near lead depositions, the results were alarmingly skewed toward minority and underprivileged communities. Black communities within 1.5 kilometers of lead facilities composed 22% of the study. Hispanic communities within 1.5 kilometers of lead depositing facilities composed 30%. When average emissions around students were calculated, the inequality in lead exposure could be seen in almost every geographic area. Most of the lead exposure was concentrated in communities that overlap racial and income disparity sectors. Transporting and disposing lead-contaminated soils in communities with less regulatory restrictions for the proper handling of hazardous waste poses an increased environmental and public health risk to Native American and tribal communities. The most frequented landfill used to dispose of California's contaminated soil is located in Yuma, Arizona, just a few miles from a sacred Native American reservation and a few miles from the Colorado River. Municipal landfills inherently have less protections for containing and preventing exposure or release of harmful toxic substances into the environment than permitted hazardous waste landfills. The Exide facility was an infamous example of one of the largest illegal depositions of lead in California. Oh my goodness, I apologize. I had to take a brief moment there because actually a 5.8 magnitude earthquake just happened. So I guess that's one of the benefits of living in California. As we were discussing, the Exide facility is one of the most infamous examples of illegal depositions of lead, and it has, decades later, still plagues the southeast Los Angeles residents, which are primarily lower income residents and Hispanic households. Harmful pollutants tend to adversely affect populations with less resources to protect themselves against harmful exposure. My project is showcasing distributive justice by how environmental harms, including lead contamination, are disproportionate to lower income and minority communities. Marginalized communities often find themselves bearing the burden of heavy pollution. These communities are frequently zoned near sites with less regulatory oversight, like the municipal landfill near the Native American reservation in Yuma, Arizona. The uneven distribution of harm clearly shows the need for reform for a more equitable approach toward managing hazardous waste. The recognition justice is how polluted communities are not given a voice, and those affected by lead contamination have been left out of the conversation when it comes to environmental decision making on their behalf. The harmful impacts of contamination are often overlooked or unmonitored. People affected in these areas do not get the resources they deserve, nor are they given a meaningful role as a stakeholder in processes affecting the health and their environment. Procedural justice. Current hazardous waste management, when it comes to the transportation of contaminated soil, does not take into the account the health of the communities it affects. The system itself is flawed, and it opens the door for negligent and harmful practices. Restorative justice can be implemented by improving the treatability locally that can help address restorative justice because it focuses on the objective of bioremediation to clean contaminated soils and avoids perpetuating harmful practices through transportation. In my case, it is about addressing the environmental damage caused by lead contamination and making things right for the communities affected. Lead is a highly toxic and harmful component to humans of all ages, and no one deserves to be exposed in either acute or chronic conditions. The main energy injustice conveyed in my project can be mitigated by three components. The first component is lead capture technologies at the source of the deposition, more responsible hazardous waste management at processing facilities to prevent initial release into the environment. Secondly, electric freight vehicles can be implemented with solar energy infrastructure and batteries for recharging. And three, eliminating the need for transport or disposal by treating contaminated soil with biological remediation methods either on site or a treatment facility nearby for the contaminated soils. The energy injustice perpetuated by the current heavy metal contaminated soil remediation methods of physical extraction and abatement is adversely affecting the environmental health and quality by contributing to needless emissions of disposing of hazardous waste generated in California and irresponsibly displacing the waste in a state with less regulations, less protections, and to avoid the proper cost of disposal. My group members and I unanimously agreed that the brunt of the responsibility should lie on federal, state, and local governmental organizations, whether that be through policy enforcement or site remediation. Additionally, the industries involved should also take accountability. Based on my three-pronged approach to reduce energy use impacts to human health and the environment for my project, there are several entities and responsible parties that can and should address the injustices occurring. Industrial and commercial sources of lead deposition can take accountability for the implementation and maintenance of lead capturing technologies to prevent lead deposition in critical communities. Transitioning the energy source from fossil fuel reliance to a renewable energy source, the remediation usually involves governmental agencies or consultants. The governmental agencies and/or private entities involved in the remediation of contaminated soils are responsible for evaluating the cost-benefit analysis of needlessly inefficient equipment in pursuit of remediating contaminated sites. Addressing energy injustice through my energy analysis will directly translate to the research of the effective use of bioremediation methods for the treatment of lead-contaminated soils. Tackling reducing emissions that are attributed from current site remediations will improve the possibility of treatability for contaminated soils. The treatment of contaminated soils generated in California and treated within the state which it is generated would inherently reduce our energy use significantly. The treatability or biological remediation of contaminated soil will also reduce the amount of hazardous waste, precluding substantial volumes of waste from being destined for a landfill for the rest of its life and end-of-life cycle. Remediating lead-contaminated soil below hazardous waste classification thresholds conserves an invaluable and finite natural resource, soil. Diverting contaminated soil from disposal in municipal landfills with less protections in sensitive locations will reduce the risk of exposure to create a more equitable hazardous waste management system.